Hi guys, today I'm going to explain question number 23 in physics section 2, page number 245. Okay, so let's start reading the question to find what is the givens and the not givens. Challenge question number 23 is a challenge question. How much thermal energy is needed to change 3 multiplied by 10 raised to 2 grams of ice? It's an ice. What is the substance? It's an ice. Okay, ice. And here, what is this? At minus 30 Celsius to water vapor. What is the water vapor? Is like a gas. And here is a solid. Okay, at 130 Celsius. So this is the given, given. I will put like a circle above the givens, and this is a given. Okay, so let's change the color and do another thing for this question. What is the not given? Ng. Not given is the thermal energy. Thermal energy is not given for this question. So we start from point A, which is the solid or ice. We can call it ice. Yeah, and its temperature is minus 30 Celsius. Okay, at minus 30 Celsius. And the point that we need to reach is 130 Celsius. Okay, so what should we do? We will pass for all of these steps to find the final thermal energy. So 1, 2, 3, 4, 5. 5 steps that we need to follow. Okay, let's start another color. Let's do it as blue. Okay, let's start. What we'll do now, how much thermal energy is needed to, we need for the first one, the equation of Q equal to mc delta T. For the second one, Q equal to M and the heat of vaporization or heat of fusion. Let's delete it. Okay, it's heat of fusion, and here it's all equal Q equal to M C delta T, and here mass into heat of vaporization, and here Q equal to M C, here it's M C delta T. So each step is different from the previous one, and now we will follow for these 5 steps to find the final temperature or the final thermal energy, not the final temperature. Okay, let's start. First, Q1 would equal to, what is the Q1? Here, Q1. I have the equation, I will substitute only in there. So I will make a Q1 equal to and what is the mass? We should convert it always to kilogram, not to gram. So it will be 0.3 kilograms. Because in physics, the main unit that we should use is the kilogram, not the gram. If you have a gram, you should convert it to kilogram. But if you have a meter or kilometer or something else, you need to convert it to meter. Like that. And if you have the time in minute, you need to make it in seconds because physics requires these things. Now, after that, what is the second given after the mass is the specific heat. What is the specific heat of ice? We found that the specific heat of ice is 2060 from the schedule that we have in our book. And what is the temperature? Temperature of this equal to, here at the starting of melting point it's 0, and he tells us that it starts from minus 30. So minus from the final temperature, this is the final temperature, from the initial temperature. We subtract them to get the answer. So 0 minus minus 30, and it will become plus. So here, this 0 minus 30 will equal to plus, and then Q1 will equal to, the answer would be in the calculator 18,540 joules is the first answer. Okay. And here we're gonna do the second step of our question, or second equation. The second one is equal to Q equal to M heat of fusion. Because it's constant, the state will change in here. Not only changing in temperature, the temperature is constant and the heat will change. So what is the second equation? Equal to Q, I'll put like this, Q equal to, what is the mass? Like we said before, is 3.0 or 0.3 multiplied by, what is heat of fusion of the water or of the ice? The heat of fusion is 3.34 multiplied by 10 raised to 5, like in this schedule, but you need to understand it and take it in here. Okay, this is the heat of fusion, and the answer would be for this second Q 100 and 200 joules. This is the second part of our question, and let's do the third part. The third part of our question is requires the same as the first equation, which is Q equal to MC delta T. So we will need only to substitute what is the mass is 0.3 multiplied by what is the specific heat of water. Specific heat of water is 4180 or 4180. 4180 is the specific heat of water. And then what do we have also? What is the temperature? The final from the initial. The initial temperature is at 0 point or 0 temperature, and the final at the starting of boiling point is 100 Celsius. So from 0 Celsius to 100 Celsius. So we will subtract from the final the initial one. It will be 100 minus 20 or minus 0, and this will equal to 125 400. 125 400 joules. This is the second one, or the third one. Now we will calculate the other one, which is in there. What is the other one? We finished the 3 tutorials, and now we are in the fourth level, which is the heat of vaporization. So we should calculate the heat now. The heat would equal to heat of the mass and the heat of vaporization. The mass is equal to 0.3, like the question before, and multiplied by what? What is the heat of vaporization of our equation? It's 2.26 multiplied by 10 raised to 6. Okay, and this will equal to, what is the answer of this in calculator? It will equal to 67,800 8,000. Okay, 8,000, and the unit of it, of course, it will be joules. And this is the fourth step of our equation. After that, we have the fifth, and then we will add them together. Now, the fifth step would be this, which is the water vapor. So to calculate this one, the water vapor, it's here. To calculate it, we need the equation of Q equal to mc delta T. So we need to substitute 0.3 multiply. This is the mass. What is the C? What is the water vapor? Specific heat of water vapor. It's 2020, like as mentioned in this schedule. In our book, we have it 2020. So the specific heat is 2020. Multiply by what? What is the temperature from the final to the starting of boiling point? The final is 130 and the starting of boiling point is 100. So 130 minus 100 into brackets, and it will equal to, the answer would be, for the last Q of our equation, it will be 18,180 joules. And this is the last thing of our solving steps. Now after that, we need to add all of these values together to find the final answer. First, this is the first value. Oh, I think it not like that. Oh my god. Okay, now I will do it here. I will highlight it, what I will take together to calculate it or to add it together to find the final answer. We have the first step, second step, and the last step. I will also highlight it there. In here it will be the first step, here it will be the second step, and here it will be the third step, and here also the fourth step, here the fifth step. So let's add them together to find the how thermal energy, the total thermal energy that is needed in our question. So how to calculate the total? Q total will equal to, or Q total in the pen. Okay, we'll erase this. Here we have Q total. Q total would equal to Q1 plus Q2 plus Q3 plus Q5 or Q4. After 4 we have Q5, and this would equal to, after adding this, Q1, Q2, Q3, Q4 and Q5, the answer would be in here. The answer of Q total would equal to, what is the final answer? We will calculate it, and it will be 94032 joules. This is the final thermal energy, and if we need it in scientific notation, here it is the scientific notation. Let's see it. Okay, it's 9 point. Okay, here it's scientific notation is 9.4 multiplied by 10 raised to the power of 5 joules. Why we wrote here? Because 9.4, we put the point here. How much the terms after the point. Here we can count 1, 2, 3, 4, 5. So that's why we put it raised to 5. Okay, and this is the last thing of our question, and I hope that you understand the question carefully. And don't forget, guys, to put like, share, subscribe on my channel in YouTube. And thank you very much. This is the final answer, or this is in the scientific notation. Bye bye for all of you.